Hello everyone, in this video we will start with module 4 and fourth module mainly deals about virtual memory management. So background for virtual memory management is if you load complete program to the main memory, then the size of the main memory is limited, so you cannot execute multiple programs, or it is like degree of multiple program will be reduced. Number of multiple programs executed at a point of time will reduce because the RAM size is limited compared to the secondary storage device. So to avoid that, instead of copying entire program which is not required at all the times, you can go for partially loading the program, which provides program to like multiple programs to load in a RAM or load in a limited main memory space. So it increases the degree or multiple programs running at the same times, and it also utilizes CPU throughout the time of execution, because the degree of multi-programming is increased, so that throughput increases. So this came to the need of virtual memory, where your logical memory space is separate from physical memory address, where the CPU thinks complete program is already in the main memory, and that is a logical view of CPU, where physical memory, only the part of the data which CPU is requested will be, or the process which is under execution will be stored in RAM. So this allows more efficient in process creation. The programs run concurrently, less input output is needed because swapping is done from main memory to storage, or storage to main memory with smaller blocks of data, and the overall it increases the throughput and efficiency of CPU. So this gave the concept of virtual memory. So to understand virtual memory, first we should know what is virtual address space. Virtual address space is the logical view of a process data. Means logical view, we already saw what logical address is. So that logical addressing is called as virtual address space. So this virtual address space can be implemented, or virtual memory can be implemented with the help of demand paging and demand segmentation. So here we have virtual memory view. Let's consider there is a process 1 which is having V number of pages from 0 to 1, and it is stored process P1 is stored in some parts of storage device. So until in the main memory, which is RAM, may not have complete 0 to V number of pages stored. What it does, there is a memory map, like we had page table and all. So a memory mapping unit or memory management unit will work in between. So it will get the page numbers. If it is page number, then the page table will act as memory map page table, and finds for the frame number in the physical memory. If not, it will go to memory management unit, will go to secondary storage, get the frame, store in the physical memory, then it will be accessed to the CPU. So since a block, like a limited size of a frame is filled with a page, the size of the page is limited and small compared to complete program, copying or swapping of data, swapping of page from secondary storage to physical memory will be easier, and it will be faster compared to loading complete program at once, and the page will be provided to the CPU in very less time if it is not in physical memory. If it is in physical memory, the CPU will get the page when it is requested. So for a CPU in the logical or virtual memory space, it feels like pages is in order or in the sequence. The program which is divided into n number of pages are in order of the sequence stored in main memory, but here memory map unit or memory management unit taking care with the physical memory to provide logical view for a CPU. That logical view is called as virtual memory. So what is virtual address space? Usually it is like designed logical address space for a stack to start at a maximum logical address, and it grows down while heap grows up. So like a process control block data, what we have a stack, we have a stack and heap. Stack grows downwards and heap grows upwards. Data and code which keeps global variable as well as program execution code. So maximize the address space use, and unused address space between these two is a hole. Yes, the data which is not used in between stack and heap is called as heap. So no physical memory needed until heap or stack grow to a new page. Again, the stack and heap is also segregated into a pages. Then like a page is given for a stack and a page is given for a heap. Until they grow bigger than one page, there won't be any free memory allocated. If the stack or a heap grows bigger than one page, then a new page will be allocated to minimize the free space wastage. Virtual memory allows files and memory to be shared by multiple processes through page sharing concept. So shared library using virtual memory, like how we saw shared, we can share the data. So consider we have two process data where code, data, heap and stack are separate from each process. Like if it is process 1 and if this is process 2, if there is a page which is shared like a library, then there will be one page stored in the main memory which is accessed by both the process. So the shared library in logical or virtual memory looks it is inside the process control block or inside the process data, but actually a single page is shared between both the process. So the address which is specifying the shared page is same for both the process. So it looks in a virtual memory that the page is separately given for each process. So I hope you understood these topics. Thank you.